The sky darkens, the wind howls, the rain lashes down. For centuries, storms have captivated and terrified us. But what exactly are these forces of nature? Join us as we delve into the science behind the storm. At its heart, a storm is a disturbance in the Earth's atmosphere, often characterized by strong winds, heavy precipitation, and sometimes dramatic electrical activity. They arise from imbalances in temperature and pressure. Think of a storm as a recipe. You need certain key ingredients to brew one up. First, moisture. Warm, humid air provides the fuel for clouds and precipitation. Second, unstable air. When warmer, less dense air lies beneath cooler, denser air, it creates an environment ripe for rising air currents. And finally, a lifting mechanism, something to get that air moving upwards. This could be a front where warm and cold air collide, or even the heat of the sun warming the ground. Not all storms are created equal. They come in a variety of forms, each with its own unique characteristics. Thunderstorms. Perhaps the most common type, thunderstorms are characterized by thunder and lightning. They form in unstable air with sufficient moisture and lift, leading to the development of cumulonimbus clouds. A typical thunderstorm progresses through three main stages. It begins with rising currents of warm, moist air, called updrafts, forming a cumulus cloud. This is the cumulus stage. The cloud then grows taller, becoming a cumulonimbus with both updrafts and downdrafts. Ice crystals form, leading to rain and potentially hail, along with lightning. This intense period is the mature stage. Finally, the downdrafts dominate, cutting off the warm air supply, and the storm weakens in the dissipating stage. While awe-inspiring, thunderstorms can be incredibly dangerous. Lightning, a rapid electrical discharge, can cause fires and electrocution. Hail, lumps of ice formed in strong updrafts, can damage property and cause injury. Powerful strong winds from downdrafts can down trees and cause structural damage. Heavy rain can lead to dangerous flash flooding. And in severe cases, thunderstorms can even spawn violently rotating columns of air called tornadoes. Hurricanes, typhoons, and cyclones are all the same type of storm, intense low-pressure systems that develop over warm tropical or subtropical waters. The regional name depends on where they occur. Hurricanes in the North Atlantic and Northeast Pacific, typhoons in the Northwest Pacific, and cyclones in the South Pacific and Indian Ocean. These massive storms are characterized by sustained winds of 74 miles per hour, 119 kilometers per hour, or higher, and a distinct organized circulation. They draw their energy from the warm ocean surface. A mature hurricane features a calm eye at the center, surrounded by the intense eye wall with the strongest winds and rain, and spiraling rain bands. Winter storms. When the temperature drops, storms take on a different form, bringing snow, sleet, and freezing rain. Winter storms occur when near or below freezing temperatures meet atmospheric moisture and a lifting mechanism. Snow forms when the entire atmospheric column is below freezing, allowing water vapor to deposit as ice crystals. Sleet occurs when snowflakes partially melt in a warmer layer and then refreeze as ice pellets in a colder layer near the surface. Freezing rain forms when snowflakes melt completely in a warmer layer and then refreeze upon contact with surfaces below freezing. Winter storms pose several significant hazards. Heavy snowfall can disrupt travel and cause power outages. Ice accumulation from freezing rain creates treacherous conditions. Blizzards, with strong winds and reduced visibility from blowing snow, can be extremely dangerous. Tornadoes represent violently rotating columns of air that descend from thunderstorms, distinct in their intense and localized destructive power, and are classified by the damage they inflict on the enhanced Fujita scale. Tropical depressions and tropical storms are the initial, less severe phases of tropical cyclones, characterized by defined circulation and increasing wind speeds, bringing threats of rain, wind, and coastal flooding. Extratropical cyclones, prevalent in mid to high latitudes, and including the impactful coastal nor'easters, are large-scale weather systems driven by temperature contrasts, resulting in a variety of weather conditions. Ice storms are unique winter events where freezing rain forms a hazardous glaze of ice on surfaces, leading to weight-related damage and treacherous conditions. Dust and sandstorms occur in arid regions where strong winds lift substantial amounts of fine particles or larger grains, drastically reducing visibility and causing potential health and environmental impacts. Lastly, hailstorms are characterized by the fall of ice lumps formed within strong thunderstorm updrafts, with the size and density of hailstones determining the extent of potential damage. The raw power of a storm is evident in its wind, rain, and most dramatically, lightning. Wind in storms is driven by pressure differences. Air flows from areas of high pressure to areas of low pressure, attempting to equalize. The greater the pressure difference, the stronger the wind. In thunderstorms, powerful updrafts and downdrafts create localized pressure differences. In hurricanes, the intense low-pressure center drives extremely high wind speeds. And large-scale pressure systems in winter storms can produce strong, persistent winds, especially in blizzards. Rain forms when water vapor in the air condenses into tiny water droplets or ice crystals that grow heavy enough to fall. As warm, moist air rises and cools in storm clouds, water vapor condenses on microscopic particles. In warmer clouds, droplets collide and merge, growing larger until they fall. In colder clouds, ice crystals grow by attracting water vapor and may melt into rain as they fall through warmer air. Lightning is a discharge of electrical energy in the atmosphere. It occurs due to the separation of electrical charges within a storm cloud, with positive charges typically accumulating in the upper part and negative charges in the lower part. This induces a positive charge on the ground. When the electrical potential becomes strong enough, a stepped leader of ionized air descends from the cloud, and a positive streamer rises from the ground. When they connect, a powerful return stroke of electricity illuminates the sky. Lightning is incredibly dangerous. Seek shelter indoors immediately during a thunderstorm. Stay away from windows, electrical appliances, and plumbing. If outside, avoid high ground and metal objects. If your hair stands on end, crouch low to the ground. Our ability to track and predict storms has improved considerably. Satellites provide a crucial bird's view of developing and moving storm systems. Radar allows us to monitor precipitation intensity and track a storm's movement in near real time. Weather stations on the ground supply essential data on key atmospheric variables like temperature, pressure, and wind. Sophisticated computer models integrate this vast amount of information to forecast the potential path and intensity of future storms, offering us valuable lead time for preparation and response. Storms can have a profound impact on our world, both destructive and, in some ways, beneficial. The destructive power of storms can lead to flooding, property damage, and loss of life. However, they also play a vital role in the Earth's systems, distributing heat and moisture across the globe and replenishing vital water supplies for ecosystems and human use. Storms are a powerful reminder of the dynamic and ever-changing nature of our planet. By understanding their science, we can better prepare for their impact and appreciate the incredible forces at play in our atmosphere. Storms, from the everyday thunderstorm to the massive hurricane and the chilling winter blizzard, are powerful atmospheric phenomena born from the interplay of moisture, unstable air, and lifting mechanisms. Their impact extends to the wildlife that must adapt to these often harsh conditions, and our understanding and ability to predict these events have been revolutionized by technology like satellites, radar, and sophisticated computer models. While the raw power of storms can be destructive, they are also integral to our planet's systems. Now, we encourage you to continue exploring the fascinating world around us, from the intricate lives of wildlife adapting to their environments, to the cutting-edge technology that helps us understand and prepare for natural events. Subscribe to our channel for more in-depth explanations of natural phenomena and scientific concepts. Don't miss out on future explorations of our dynamic Earth and the amazing ways both nature and human ingenuity shape it.